Welcome back. This is the fourth video in showing how to solve the process synthesis problem using ProCAFD. In the third video, we have completed until step 3 or the process group selection and options in solving the cumin production problem from propylene and benzene. So the next step here is to generate the flow sheet, which is step 4, and for that the user has to select this button here. Before that, just to show that I haven't selected any options here, which means that I intend to generate all the feasible flow sheets available for producing cumin from propylene and benzene. So now let's go to the next step. Here, as you can see, the tool was very instantaneously generating all the flow sheets, and as you can clearly see that these flow sheets are actually stored in a very are stored in an ASCII string format, and this is inspired, or this work is similar to the Smiles representation of a chemical compound structure. So each and every string which are shown here represents a different flow sheet for production of cumin here. So let's see how many alternatives the tool was able to generate. So the number of alternatives it was able to generate were close to 240 alternatives for the cumin production problem. Here the user has the opportunity to see the process topology of each and every alternative here. So all the user has to do is to click any of the view button here, and he should be able to see the process topology of that particular alternative. Let's go and see one example here. So here I've selected one, and you can see that this is one process alternative where the downstream separation network has three different distillation columns here. Similarly, the user has an opportunity to actually select any of the alternatives here. Now let's just go back once and see how the options here will change the generation of flow sheets. So let us say, okay, I only want distillation columns as my downstream network, separation network. So let's see how many alternatives we will generate. So the tool was able to generate only 10 different alternatives, which only distillation columns and flash separation units. So this is how the user can actually remove or select different options based upon his choice or his company's choice here. So now let's go to the next step, which is called as ranking of alternatives. So the user has to select this button to move forward. So once I select this, you can see that the alternatives have been ranked with respect to different target properties like energy index, carbon footprint, etc. So all the user has to select is to click on any of the button here or any of the ranked target property here, and the alternatives will be ranked accordingly. Now I have selected alternatives based upon energy consumption, and you can see that I found this alternative has the least energy index, and all of the alternatives have higher number when compared to the first alternative here. And similarly, you can also see the carbon footprint here. And if you want to see the product recovery, for us the recovery here is cumin and disisopropyl benzene. So I'll remove everything else and I'll only keep these two, and I'll recalculate, and you can see that the product recovery of D and E are shown here. So this is how the user can actually rank the different alternatives, and in this step the user has to select the number of alternatives which he wants to further design and do some extra analysis or even rigorously simulate. So here the user has to click on the different alternatives, the right click, and you'll have two options called as select and remove, and the user has to select the first option, and a green color is filled on the alternatives which has been selected. Similarly, I'll select the top 3 alternatives, and in the next video I'll show how these selected alternatives will be designed and further analyzed, and in the last step I will show you how the selected alternatives are actually set up in a rigorous environment like Pro2 or ASCII to simulate and see the decision variables.